Hi, this is Pratik and welcome to Code by Pi. In this video lesson, we'll learn about level order traversal in a binary tree. Tree traversal in a binary tree are of two types. The first one is depth first traversal, and under depth first traversal comes post order traversal, pre-order traversal, and in-order traversal. Now, all these three types of traversal are called depth first traversal because they allow you to go as deep as possible in a binary tree. Now, apart from these three depth first traversal, there is one more way of traversing a binary tree, which is breadth first traversal, and this is nothing else but level order traversal, which allows you to go as wide as possible in a binary tree. That is, you travel the binary tree level by level and from left to right. So if I take for example, so this is the given binary tree and you have to do level order traversal of this binary tree, and as I said, you will travel level by level from the top, and for each level you will travel from left to right. So the level order traversal of this given binary tree would be, first you're going to travel the first level and print 1, then you're going to travel the second level and then print 2 and 3, and then you're going to travel the third level and you're going to print 4, 5, 6 and 7. But this was all about the theoretical part. But how would you design an algorithm to do this? Now for this purpose, I will take the help of a queue which will act as a temporary buffer. Now whenever you code this thing out and you make a function to do level order traversal, that function is going to take parameter as the root of the entire binary tree. So you take that root, you print that root, and you append that root inside this queue. And now you have to go to the next level and print 2 and 3. So in order to tell your algorithm to print 2 and 3 which are left and right of 1, you will pop from the queue and you're going to tell the algorithm to print the left and right of the popped item. So first you're going to print the left, and at the same time you're going to append the left inside this queue. Then you're going to print the right of 1 and again append it inside this queue. So you notice that each time you are printing the left and right of a node, you are popping that node from the queue. So each time you are printing the left and right of a given node, you are inserting the printed nodes inside this queue at the same time, and after the left and right has been printed, you are again popping from the queue. So the algorithm is something like pop, print left and print right, and at the same time append them inside the queue, and after that repeat the popping of items again and print the following steps. So it's something like a cycle, something's happening in a cycle. So it's definitely a while loop that's taking place to do all these things. So now let's move ahead. So after printing 2 and 3, you're again going to pop from the queue, and then you're going to print the popped items left and right, and in turn they will also be pushed or appended inside this queue. And after this, you're again going to pop from the queue and you're going to print its left and right, and in turn append them inside this queue. So again you're going to pop from the queue and you will try to print the left and right of 4. But 4's left and right are none and none. So in case when a node's left and right are none, you are not going to print it because you simply cannot print it. You need to put this condition while you will be coding all these steps, and you will put this none condition over here when you say that before printing the left, first check if the left is present. So if the left is present, then only print the left. Similarly for the right, if the right is present, then only you're going to print the right, else you're not going to print the right. So since 4's left and right are not present, you're going to not print 4's left and right, and since this printing operations do not take place, the loop will again continue and it's going to pop from the queue, and then again it will try to print its left and right. So the popped item is 5, its left and right are none, so there will be no print operations. Now again the loop will continue and it will pop from the queue, and story goes on same. Again it will pop from the queue, again the story is same. So it will be keeping on popping, so this loop will continue until the entire queue is empty, until everything has been popped out from the queue. So now let's code this out. So first thing comes first you need to define the structure of the node, and for define that structure I'm going to define class node, and in this class node I'm going to define a constructor which will be taking the node data as the parameter. And you need to form 3 parts of a given node: its data part, its left part, and its right part. So to form the data part, I'm going to take this node data that has been passed as a parameter, and I'm going to put it inside the data part of the given node. And when the node is formed, its left and right are none. So I'm going to write that also. Now before doing anything else, make the binary tree first. So I'm going to make an object of the class node, and I'm going to call it root, and I'm going to pass the data as 1. So the root of the entire binary tree will have the data of 1, and we will be forming the same binary tree given here. So one's left contains 2 and one's right contains 3. So in order to build one's left connection, you will say that you will form a new node having data as 2, and you will attach the new node at the right of 1. So you can form the new node by writing node 2, which means a structure of the node gets created in which the data becomes 2 and its left and right become none. Now in order to make the connection with 1, you're going to write roots left is equals to node 2. So one's left gets attached to the node with data as 2. Now similarly, you're going to make the right connection, and for that you're going to simply write root dot right is equals to node with data as 3. And similarly, you can make the other connections. So now since you have formed the entire binary tree, and now you traverse this formed binary tree level wise. So for traversal, I am going to define a function. So I'm going to call it traverse, and I'm going to pass the root of the binary tree that I want to traverse. So the first thing that you're going to do is form a queue. In Python, you can form the queue by simply declaring an empty list. And after this, you're going to check if the passed root is really a root. If it is not, none. And in that case, you're simply going to print its data. And after printing the data, you need to append that root inside the queue. And now it's time to do this operation. So to perform this operation, it's certain that you got to define a while loop. And then while loop will have to continue until everything has been popped out from the queue. So I'm going to define a while loop saying while length of the queue is greater than 0, I'm going to pop out from the front of the queue and print its left and right. So I popped out from the front of the queue and I give it the name current. Now in order to print current's left and right, first I will have to check if its left and right is present or not. So first I am gonna write the condition if current dot left is not none. So if current dot left is present, then I'm going to go to its left and I'm going to print its data. And after printing its data, I'm going to append that inside the queue. I'm going to print the right in a very similar fashion. Again, I will first check if current dot right is not none. And in that case, first I'm going to print its data and then append it inside the queue. So this while loop is going to continue until the length of the queue finally becomes 0. Now let's call this traverse function inside the main, and let's do the entire traversal. So here we go. So first we call the traverse function and pass the root of the binary tree that we want to traverse. I save this program and I run it. Okay, so here we go. So yeah, this is what we wanted. First it traversed 1 and printed it, then 2, then 3, 4, 5, and 6, and 7. So this is it, guys. This is how level or traversal has to be done in a binary tree. I hope that you understood it. Like, share, and subscribe to the channel, and thanks for watching.